Hello calculus, welcome to Quotient Rule. This is what you did with Miss Radke when she was here for me last week. So this may look a little different or sound a little different than you heard in your notes. Alright, the first thing we're going to do, we're going to be doing Quotient Rule today. We did Product Rule yesterday, today we're doing Quotient Rule. First thing we're going to do is we're going to divide this guy out and put it in polynomial form. So this would be f of x is equal to 2x cubed divided by x squared, that's 2x. Negative 3x squared divided by x squared is negative 3. And then 2 divided by x squared would be 2 times x to the negative 2 power. Just bringing that guy up to the top and making a negative exponent. And we're doing that so that we can use the power rule to find our derivative. So derivative of 2x is 2, derivative of 3 is 0. Derivative of 2 times x to the negative 2 would be negative 2 times 2 is negative 4. X to the negative 2 minus 1 is negative 3. So this would be 2 minus 4 over x cubed, which would be 2x cubed minus 4 over x cubed. If I found a common denominator here of x cubed, multiply this guy by x cubed, and then this minus 4. So there is our derivative. And so this leads us into the quotient rule of differentiation. I'm reading product rule, but this is quotient rule of differentiation. So if h of x is one function divided by the other, or f of x divided by g of x, then the derivative of h is going to be the derivative of the derivative of the top times the bottom minus, so product rule is positive and quotient rule is negative, the top times the derivative of the bottom all over the bottom squared. All right, so we're going to use the quotient rule on this same f of x that we had up here in our warm-up. I'm going to show that the quotient rule works. So for this one, let's call this h of x instead of f of x. This is my f of x function. This is my g of x function. F is on top, g is on bottom. So my derivative is going to be the derivative of the top, so 2x cubed. Derivative of that is 6x squared. 2 times negative 3 would be negative 6x to the 2 minus 1. Derivative of 2 is 0. So that times the bottom minus, this time we leave the top alone, times the derivative of the bottom. Derivative of x squared is 2x all over the bottom squared. So x squared squared would be x to the 4th. All right, so do some distribution. 6x squared times x squared is 6x to the 4th. Minus 6x times x squared is minus 6x cubed. We got minus 2x times 2x cubed would be minus 4x to the 4th. Negative 2x times negative 3x squared. Negative 2 times negative 3 is 6. And then I've got 2 3x's. And then negative 2x times 2 is negative 4x. All over x to the 4th. Alright, that would be 6x to the 4th. Negative 6x cubed and positive 6x cubed cancel each other out. And then, I've got 6x to the 4th minus 4x to the 4th. This would be 2x to the 4th. And then minus 4x all over x to the 4th. But they have an x in both terms up here, so I can factor out an x. That gives me 2x cubed minus 4 over x to the 4th. This x will cancel with one of these guys, and so I get 2x cubed minus 4 all over x cubed. Is that what we got up here? Yes, we did. So quotient rule does work. In this case, I think it's a little easier to do it the first way than the second way. Quotient rule tends to be a little bit more cumbersome than maybe say product rule. But we're going to get to some functions that say have cosine or sine in them, and we're not able to use the power rule. We're going to have to use the quotient rule in order to derive them. All right. Find the equation of the tangent line drawn to this graph of g of x at 2x minus 1 over x plus 3 when x is equal to negative 2. So first I need to find the point on the tangent line. So when x is negative 2, we need to find g of negative 2 to find the y value. So 2 times negative 2 minus 1, negative 2 plus 3. So plugging in negative 2 here. 2 times negative 2 is negative 4 minus 1. 3 minus 2 is 4. This will be negative 5. To find the slope of the tangent line, that's going to be my derivative. We need to find the derivative and then evaluate it at negative 2. All right, so here's my top function and my bottom function, right? So the derivative of the top is going to be 2 times the bottom function minus the top times the derivative of bottom. So derivative of x is just 1, derivative of 3 is 0. All of that over the bottom square. If I want to, I can go ahead and plug in negative 2 here, or I can simplify. I'm going to simplify it a little further. So this is going to be 2x. 2 times 3 is 6, minus 2x, minus a minus 1 would be plus 1, over x plus 3 squared. 2 x's cancel, I get 7, over x plus 3 squared. That's g of x, sorry, g prime of x, so g prime of negative 2 would be 7 over negative 2 plus 3 squared. 3 minus 2 is 1, 1 squared is 1, 7 divided by 1 is 7. So the slope of the tangent line here is 7. And so my equation is y minus a minus 5 is equal to that slope, x minus a minus 2. All right. That's it for this video. Come back and we'll do the second page of your quotient rule notes.